Now let us try to apply the knowledge we learned in the previous video to subatomic particles like electrons, protons and neutrons. Here is the experimentally measured relative mass of an electron approximately. That is, one electron is this many times as heavier as our standard, that is unified atomic mass unit. Now how do you get the mass of an electron? You know how to do that. You simply have to express its relative mass in U. And for whatever reason, if you need the mass of an electron in kilograms, you know how to do the conversion. 1 U is equal to 1.66 times 10 to the power of minus 27 kilograms. So this is the mass of an electron in kilograms, and this in unified atomic mass units approximately. Then what is the molar mass of electrons? See, molar mass is mass per 1 mole of that substance, and 1 mole of any substance contains an Avogadro's number of particles. And the particles that we are talking about here are electrons, and we know the relative mass of an electron. So the molar mass of an electron would then simply be equal to its relative mass expressed in gram per mole. Then what is 1 gram electron? It is simply the relative mass of an electron expressed in grams. So it would be 0.0005486 grams. And you know, 1 gram electron of electrons contains an Avogadro's number of electrons. So this is the mass of an Avogadro's number of electrons. Again, remember, this is old vocabulary. Now let us do the same with a proton. Again, this is the relative mass of a proton approximately measured experimentally. That means 1 proton is this many times as heavier as our standard, that is unified atomic mass unit. Then the mass of a proton would be 1.0073 U, and in kilograms it would be 1.0073 multiplied with 1.66 times 10 to the power of minus 27 kilograms. Then the molar mass of a proton would be 1.0073 gram per mole. I don't have to explain it again. And 1 gram proton is nothing but its relative mass expressed in grams. So this is again old vocabulary, and 1 gram proton of protons contain an Avogadro's number of protons. So this is the mass of an Avogadro's number of protons approximately. And the relative mass of a neutron is this approximately, and the mass of 1 neutron would be 1.0087 U, and the molar mass of neutrons would be 1.0087 gram per mole, and 1 gram neutron is nothing but its relative mass expressed in grams. And 1 gram neutron of neutrons contains an Avogadro's number of neutrons. That means this is the mass of an Avogadro's number of neutrons.